I'm Jamie Kruse. I think I'm one of the older people in the room, and I just shared with Scott that I'm probably one of the few people that had been in the infield of the horse racetrack at Exarban Field before all of this was here. So just a little bit of context there. And so I am familiar with Omaha and have been here a number of times. Okay, I think many of you in civil engineering recognize the name of John Vandelit. He is my partner. We are co-directors of the Center for Risk-Based Community Resilience Planning at Colorado State University. I've got another few titles. I'm Emeritus Distinguished Professor of Economics for East Carolina University, where I directed a Center for Natural Hazards Research, and so I've got a few other titles. So what I want to do is I'll give you a brief outline of what I want to talk about, and I'll try to I know I can't speak as rapidly as other people do, so I'll do my best to get through this without taking more of my allotted time. So what I want to do is just sort of give a brief thumbnail overview of what I consider to be called integrated models. And they require many, many different disciplines with high levels of science to make them work. So I'm going to talk about the STAR framework that's part of CHEER, which is Coastlines and People Hub. And I'm going to talk about the Colorado State University Center of Excellence that was funded by NIST that developed INCORE. And then lastly, I want to spend some time, given the title of this workshop, to talk about where I think we can use AI effectively and in ways that are beyond the research and modeling aspect, because I think there's some real opportunities when we're creating these models that we do something what I call bridging the divide. In other words, if we're creating a tool for users, it needs to be usable and used. And I think AI has a place there. Okay, here's my overview. And this is meant to be very coarse, but the idea is in these integrated models, what we've got are physical characteristics, the landscape, the building portfolio, public infrastructure, all these aspects of the built environment that support the population. And so we put that with the socioeconomic characteristics of a community. In other words, what does a population look like? Is it diverse? What are the income levels and where are they distributed within this community? Where are the social institutions, hospitals, schools, churches? And then what is the economic engine of that community? Where are people working? What businesses are located there? Okay, we take those characteristics of this community and then we couple them with hazard characteristics, which depending on the community might be earthquake, wildfire, flooding, hurricane, tornado, take your pick, tsunami. And then we usually take the model and we shock that system to look at what happens to the functionality of all these systems within the community. And then we track recovery. So we end up with something that looks a little bit like this cartoon for a single event. And hopefully what we can do is we can measure the state of recovery and shorten the time. And I want to emphasize that time is always a component of resilience. How fast can we get back online? And what level of functioning can we get that community to? So I'll start talking faster or go through. So we end up with something that looks like this flow chart, and this one was developed for INCOR. And so next, and this is in the overview part, what are the roadblocks? What are the difficulties in creating these integrated models? Number one, you're talking across disciplines. And so even the definitions of different things mean different things to people that have been trained and taken their qualifying exams within some expertise level. And so I'm going to give you an example of that. And since we're in Nebraska, especially if you asked a cattle producer 3 years ago what AI stood for, they would not say artificial intelligence. They would say artificial insemination. So, and they still do. So that's one of the roadblocks is Nathaniel Rosenheim at Texas A&M, when he was involved with INCOR from the beginning, or with the COE from the beginning, which is a 14-university consortium. He said, we spent the first year kind of looking at each other, trying to figure out what we were going to do next. And so definitions, different and possibly inconsistent objectives of the different researchers that are contributing to this integrated package. And then we get into the issues of data. And we've talked about that a little bit already today, about availability. Can you get it to conform to the rest of the inputs needed in the model? And so this conformity in both time and space, unit of analysis, are always a challenge when you're trying to integrate across. And then thirdly, with data is the privacy issue. Okay, private companies may not want to share the information that you need to make the model work. And then there's the issue of PII, private identifiable information that protects the privacy of every individual. So those are challenges when you're trying to create this holistic picture. These things are complex. We all agree. Even a subset of these models is complex. Validation, if you are actually creating a tool that you expect a decision maker to use in the future, you need to have some sense of whether or not when you say something is going to work in a certain way, that it does. And then the usability of this model. Okay, so I'm going to start by talking about two of the projects that I've been involved with. And one is called the CHEER project. And the idea is, can you identify policy levers that reduce hurricane risk in an equitable way that includes a viable and profitable private insurance market and a vibrant regional economic engine? Okay, and can you do that where the stakeholders will buy in? You're not imposing a regulation on anybody. Okay, so this is just a thumbnail description of CHEER. It stands for Coastal Hazards, Equity, Economic Prosperity, and Resilience. It's a Coastlines and People Hub. Thank you, National Science Foundation, for funding. The impetus for this probably started somewhere around 15 years ago with the first modeling attempts. But it focuses on hurricane, residential housing, as I said. It incorporates a private insurance industry. It looks at mitigation measures such as buyouts and retrofits. And it has a stakeholder perspective, and usually we're looking at about a 20-year time horizon. Okay, so this is kind of a thumbnail. The STAR model is game theory based. It uses a Cournot model to model the interaction between the homeowners that are purchasers of insurance and people that mitigate their homes, and a profit-driven insurance industry. Okay, the third stakeholder is what we call the government, or a government decision maker that approaches this as what I would call a Stackelberg model, in which that government decision maker is trying to find the best solutions relative to some objective function. And so this, I think that kind of summarizes this a little bit, but this STAR model, it's a consortium of about 8 universities. University of Delaware is the lead. Okay, so this is an example of some of the output of one of the studies, and this is looking at how much of hurricane loss exists for the case study area of eastern North Carolina. How much can we mitigate? How much can we solve or reduce losses with insurance? And all of this with not 100% compliance of individuals, because people don't always do what you want them to, right? So this is just an example of one study. And then since we're doing AI, I actually did some information gathering in the old-fashioned way. I asked some of my colleagues for their opinion as to how we might improve or expand this model using different AI methods. And so this is from Ian Soo Wing, Boston University, and the idea that he's putting forth is we can really use some of these high-dimensional pattern matching problems using deep learning models to match people to housing. But I also wanted to include the first sentence, because he said we can easily observe structures and model the impacts of hazards on them and their resilience to them. And I think many, many people in this room would not necessarily agree with that statement. So, and he's an economist. So I just wanted to share that one with you, because I think a lot of work needs to happen in all areas here. Okay, a couple of places where AI has been incorporated into the STAR model is one of my complaints about to my colleagues about looking at a 20-year time horizon is that that building stock changes. It's not stagnant. It's not static. And so how can we incorporate the idea that the building stock and housing is going to change as people move in, people move out, the stock ages, there's new building, and all of this is driven hopefully by increasing opportunities for jobs. And so this is one place where a modified housing inventory projection model was created using machine learning. And so there's a couple of citations there. The other piece on that is this is in development for the STAR model is they're using generative AI to look at individual attributes and also to assign people to different types of housing. Rental housing is something that is oftentimes ignored. And so this is one of the areas, but those are a couple of applications. And next I want to talk about INCORE, which I look around the room, Elaine Sutley, who will speak next, Andreas Gonzalez Fuertes is speaking next, Omar Nofel, Milad Ruhi have all been involved with that 14 university consortium. Okay, so this is sort of a thumbnail of what this community resilience overview, the Center of Excellence, is about. The first 5 years was about generating the science, and the second 5 years was about knowledge implementation. But I want to point out something, because INCORE, the product that has been developed from this is open source. That means anybody can use it, and we hope that you might consider using that or pieces of that to enhance your own research. Okay, this, my colleague John Vandalik shared some slides with me, and this is one of his slides, and he says, wouldn't it be great if we could predict the probabilities of individual building level using physics so it is transferable anywhere, predict just how many and which households will dislocate based on their characteristics? Can we predict changes in the community level incomes by those household demographics? And can we have that information provided in a way that resilience-informed decision-making can take place with the objectives for those decision makers, which might include preserving the economic engine, making sure all populations are taken care of, and so on. Okay, there are 4 stability areas that INCORE addresses, and that's population stability, economic stability, the stability of social services like healthcare and education, then physical services, which is how many buildings are functional? Do they do what we need them to do? Okay, including also the infrastructure. So this is another thumbnail of what INCORE integrates, which is very different from the STAR model. If you think about what the STAR model is, it was very stakeholder oriented. This has a different orientation. And so when we look at that, we start with the community model. I bet that picture of the little building archetypes came from Omar Nofel. And we use something similar to input-output analysis called a computable general equilibrium model to represent the economy in that community. And so both of these rely on something that's rather tedious to construct called a social accounting matrix. And I think Heba described it in her presentation. Okay, there's that. Again, we don't need to talk about it. Okay, so I'm just going to show you very briefly one of the partner communities that we worked with, and this is far from the number of slides that are related to this. And I also want to recognize that Milad Ruhi was a real spearhead in our interaction with Salt Lake City. And so let's see, we've got 53,000 buildings, 34 different archetypes, population around 200,000. And so then what we do is we look at an earthquake that is affecting this county. And so these are some of the simulation results. And this is the most probable damage state with or without an investment in retrofitting. Salt Lake City was very interested in something called the Fix the Bricks program. And where do you spend the money to help people reinforce their masonry? And so this was part of the information that they got as a community. This is the building functionality under the same scenario with or without an investment. And that's all I'm going to show you. I mean, the other presentations would show you many, many more of these figures. And so we're going to ask you to go online. And this is one of the things we've done is we've launched a website called incore.org. It's in-core.org. There's the URL. And there you can either learn a little more about it or you can sign up for an account. Okay, we also have a YouTube channel. And the upper link is one that allows you to get an overview of InCore, and then we have a testimonial from the users in Salt Lake City that are using the information from InCore then to put it into grant proposals, mitigation grant proposals, to see if they can do even a better job of funding their work. Okay, so I'm referring you to Andreas's presentation that has some component that is related to InCore, and also Elena Sutley, who is coming up right after me, who is going to refer to some of the work in InCore. The other piece that is, I don't know that either one of them are going to talk about, is computable general equilibrium requires a social accounting matrix. These are tedious to create. And then the best package to run this through is something called GAMS, which is a proprietary package to do CGE modeling. Now, Andreas's colleagues at University of Oklahoma use machine learning along with a CGE model and a bunch of hazard scenarios for, say, like Salt Lake City, to create a version that goes into InCore that is much faster in its calculation to come up with the economic impacts. And so that is probably the most profound application of AI within InCore right now. Okay, what are the opportunities for modeling and for dissemination? Okay, I think we started out by talking about data. That is going to be a real game changer, especially when we can fill in the blanks for sparse data, and for other countries, especially where the data is not nearly as available as it is in this country. We can use algorithms to format these data so they conform with the needs of the modeling package. And then lastly, we can address the issue, and we are addressing the issue of PII, in other words, by creating synthetic populations, so that we can look at the impact on the community without violating anyone's privacy. Okay, complexity. Well, I think that this is a real opportunity here, both on the modeling side and on the user side. We can right now, we can ask for Python code as long as we know what we're looking for. The only caveat on that is that you need to test it to make sure you're getting what you thought you were getting. I think most people agree with that. And also, I am so impressed with the coaching aspect. I've seen the demonstration of two examples in which the coaching for someone that is studying or the coaching for someone that has a computer problem will come back with answers, and very personable answers to questions. Validation. I think this is an opportunity where we can create stress tests for the models, especially in the area of tail risks. And usability. This is the case where we can use chatbots, we can use coaching for individuals that understand their community very well, but they may not know how to make this complex model work. And the other thing that AI is being used all over the place for generating written words. The people that we worked with in advertising that helped us with our YouTube videos said that they use it to generate the first draft of text. I understand that in the legal profession, very standard documents are now being generated with AI. The one question I have is, what is the hourly rate that they are going to charge us for that? Okay, and so for those people that are writing mitigation plans, writing reports, creating grant proposals, if we can use AI to, this is my vision, if we can use this model that is going to fill in the blanks and help them write the report so they can, especially an under-resourced community, so that they can get the money to mitigate properly, that would be a real winner. Okay, I've got one more thing, and this is, I'm going to share with you, hopefully. And this is the newest development, and not too many more slides and just a couple minutes on this. Okay, In-Core Studio was created to help address the issue of trying to make In-Core work with its data and modeling requirements. And so this is going to be a GUI interface without Python coding, and I'm going to move to this. This is a very short demonstration, hopefully. Okay.
This is design markup for In-Core Studio. I'm going to walk you through the capability of In-Core Studio with this design markup. Current window you're seeing is a sign-in window. Let me sign in. After you log into In-Core Studio, it shows you the list of projects. In-Core Studio allows users to organize community resilience analysis as a project. You see 2 projects here. I'm going to open Joplin Hindcast Tornado Analysis. When you open the project, you will see the dashboard. This dashboard shows you the component of the project. The project consists of workflows, hazards, and visualizations, data sets, and DFR3 mappings. So you are able to see all those things you need for community resilience analysis. So for example, now if you click on this hazard, then you're able to see preview of 2011 Joplin Tornado Hindcast. Now let's create a new workflow. In In-Core Studio, workflow means chained analysis. In other words, series of analysis that consist of community resilience analysis. Let's give a name, workflow, and description. And then, next screen, it shows you all the list of analysis available in In-Core. Now you need to select one of analysis to start. Let me start the building structure damage and add to workflow. Then it shows the structure of a building structural damage analysis. It shows the input data sets and output data sets. Now I want to chain next analysis, so click Add New Analysis. Now you see that the analysis able to chain with the building structure damage analysis are highlighted here. So I'm going to select Monte Carlo limit state probability analysis and add to workflow. Now these 2 analyses are chained to the output of building structure damage to input to Monte Carlo limit state probability. Let me add one more analysis. Now you can see other analyses are highlighted that are able to connect it with Monte Carlo limit state probability analysis. Let me select the building functionality. Add to workflow. So now I have 3 analyses are chained together through the data sets input and output. So when you finish editing the workflow, I can click Done to finish the workflow, finalize workflow. When you finish editing workflow, now you are able to execute workflow. So let's click on Execute Workflow button. Now you need to give the name of execution and then click Execute Workflow. Then right side panel shows up that you are able to set input data sets and parameters for each analysis. Now you see building structural damage analysis highlighted, and all the input data sets and parameters it shows for structural damage analysis. Now you finish entering all that. Let me move to building functionality. Now we change to different input data set and parameter. Especially it shows that one of the input of building functionality analysis are connected to Monte Carlo limit state probability outputs. When you finish setting up all input and parameter, now you are able to run. So click Run button. Then it shows the progress of each step or each analysis. So when you finish one step, and then go to the next step, and finalize the last step. When it finishes, you're going back to the workflow diagram showing the output and inputs. The difference is now all the outputs are populated, and also right side panel shows the results, which is outputs organized by each analysis. Let me click on this one, that one of damage output from building structure damage analysis. You see that this is highlighted in the diagram also. So this is the way that you are able to interact with the outputs of your workflow analysis, and also you navigate through what kind of outputs generate from each analysis. And there's another way to look at the outputs through the visualization. So let me click this button, which shows that add to visualization. In Core Studio, you can create visualization like a geospatial map or chart. So this one shows you that where your data set going to add to which visualization. In this case, I'm going to create a new visualization, and I need to give the name, and then select the type of visualization, and give some description, and then create visualization. Then it shows a drawer from the bottom that shows that this is the name of visualization and what data set are added to this visualization. After you add all the data set you are interested in to visualize, now you can click this button to show actual visualization. So this one shows that building structure damages in the Joplin area. You are also able to pop up this layers panel, shows the list of the data set included in this visualization. In this case, this is a damage output from building structure damage. And also, if you click on this data set, it pops up the tabular format of the output of this data set, so you're able to navigate these outputs in the tabular format or geospatial map format. And when you close it, when going back to the dashboard. So this is the design markup for Core Studio. Thank you.
Okay, so I put in a couple screenshots just to, in case my video didn't work. But I wanted to point out that that example, and incidentally, that was Zhang Li at the National Center for Supercomputing Applications. That was his voice, and they were our partner in developing Core. And so one of the things I wanted to point out is he sort of stopped at the damage analysis, but this is capable of going much farther. And I think if I can see the little writing, the machine learning CGE is the next to the last box, and then some of the tools for CGE are also possible. And so that's, I think I just skipped something here. I need to back up. Okay, this is the development schedule, and so this thing is in beta version right now. The version 1 is expected to be released sometime in June. I can't be more specific than that because we can't ask Zhang Li directly on that. That release will come from NCSA. Okay, and lastly then, I want to thank you for your attention. I know that this is different. Everybody, thank you very much. I've known some of, in these multidisciplinary cases, that people would sort of go out and check their phone when stuff that was not of interest to them was being presented. So I do appreciate your attention on this. Thank you very much.
Thank you, Dr. Kruse.